Welcome to the lecture series. This lecture today we are going to see about selective laser melting. Selective laser melting is one of the powder-based additive manufacturing process. This process, a laser is used to fuse the metallic powders. So the material is already in the powder form. A laser energy is used to fuse the metallic powders, and it melts the metallic powders uh, fully melted, and it is bonded with the another grain of the same. So this is a schematic diagram of the working of the process. So here you can see that the main components are laser beam, laser source, optical scanner, roller, then the bed. So you can see here how the object is scanned by the laser source. So the laser source supplies the power to the optical scanner. This optical scanner focuses on the powder. So initially the magazine, you can see the position of the magazine. One is in the upward direction and another one is in the downward direction. So the upward direction magazine charges the powder. So the roller is used to distribute the powder evenly on the build area. So once the roller comes from the left hand side to right hand side, it flows the material, or it distributes the material in a even manner. Then the laser starts providing the laser energy, and this laser energy or the laser beam is focused on the powder. So this through this action, the laser melts the powder, and it gets fuses, and it bonds with the another layer. So this process is continued, and the scanning takes place according to the given 3D object or given 3D model. So this is how the heat is applied over the layer by layer by the application of laser. So once the laser beam is focused on the powder, this powder fused, and it melts, and it bonds with the another layer. So this is how the process is continued. So during this process, the powder is in the powder form material is converted into a molten material, and it is melted. So later it is allowed for the solidification. So we can see how the mechanics involved, that is the from the solid state to the thermal fluid state. So in this schematic you can see here how the laser beam is directed towards the table, and it creates a melt pool, and in this melt pool the powder is melted. So this is how the process takes, and it immediately it cures, and it forms as a solid layer. So the powder is then melted, and it forms as a solid layer in order to have the desired shape. So the laser scans only in the specific areas where the 3D model is loaded in the computer. So according to the model, the layer in which the laser scans will get melted, and it solidified. So that is why this process is called selective laser melting. That is selectively the profile geometry is melted on the table or the surface area. So the remaining area, the powder will be as it is, and at the end of the process the powder will be reused for the next process. So this is how the schematic is explained previously. So you can see here it uses a CO2 laser. So you can see how the roller from the flows from the left hand side to the right hand side. So the laser source is provided on the top of the table, and it scans according to the given pot geometry. So the table moves downward, and the roller loads the or distributes the powder over the surface of the table. So this process is continuous until the entire geometry is attained. There are wide range of materials that are used in this process, such as nylon, polyamide for functional prototypes, and metals like stainless steel, aluminum, titanium can be used for high strength components. Ceramics are also used for applications having heat and wear resistance. So these are some of the examples of the products that are manufactured by using this selective laser melting process. So the advantages of this process is that it has a freedom to design. There are a wide range of materials, and it is a strong and durable parts are created, and there is no need for any post processing. So this is a high efficient technique, and the material wastage or the post processing is very effective, and there is no further cost added after processing. Whereas the disadvantage is always the 3D printing process always having a high initial cost, and the surface finish of these products that are manufactured using this selective laser molding have poor surface finish because of the uneven surface. Later uh, it should be cleaned, or it should be processed. Uh, then the limit of material properties, the you cannot use similar or multi materials in this process. That is a big advantage disadvantage of this process. And the power handling is the power energy requirements are high, and it takes longer time to build parts. So these are the disadvantages of this process. Thank you.